Good morning, everybody. It's great to be here, to see, to actually be in the UK and look around and see this much engineered timber, this much innovation at close hand is really exciting. So very pleased to be here. I'm just going to give you a whistle-stop tour through a 20-year career. So if I talk too quickly, I'm going to do so in order to make sure there's time for questions at the end. So this is us. We're Waugh Thistleton Architects. And we are passionate as a practice about the implications of the work that we do in terms of climate change and sustainability. And that has been an emerging kind of ethos of the practice over the last 20 years. And 20 years ago, well, 2000, it's not quite 20 years ago, is it? 19 years ago. Make them. We built the first CLT building in the UK. We had no idea that that's what we were doing. But we were very excited about ideas around prefabrication and thinking about how we could use low carbon materials. There wasn't really anything talked about in terms of embodied carbon that we knew, or the idea of upfront carbon was still something that hadn't really been kind of finalized or discussed, or was no more than a concept at the time. But as a practice, we had an idea that actually we should start thinking about sustainability not only in terms of energy use, but also of the building materials that we were using, and how we could do that not in a peripheral sense, so not kind of bird watching centers in Norfolk kind of sense, although they're great, and there's some lovely ones. But the idea that we would actually be a mainstream practice, and that we would involve ourselves with commercial residential developers looking at low carbon construction materials. And so we happened to come across this Austrian guy sitting on his own in the corner of this sort of kind of hippie exhibition full of hempcrete and sheep's wool insulation, and there he was with a lump of CLT in about 2002. And we were just starstruck. And then we built this little building, about 40 square meters, and I sat on my bike and watched them build it in just a couple of hours. Millimeter perfect, 2 people, cordless screwdrivers, and the whole building went together. It's like a kind of one-to-one model. There it is. It was really exciting. And from that moment on, I was taken. And so that's what we've continued to do since then. And for me, this isn't just about low carbon. It's not just about replacing concrete and steel, which is what we need to do. We need to reduce within the next 9 years, we need to reduce the amount of concrete that we use in this country by more than 50%, just to meet our current commitments. That's without inventing anything amazing. But that's not going to happen. So we need to reduce the amount of concrete and steel we use, concrete specifically, by 50%. So if you think, how are we going to do that as a society when we need a lot of concrete for infrastructure, for foundations, we need to be replacing concrete and steel in the buildings that we build. And so we see engineered timber as the only viable solution, the only viable replacement for that. And in 2008, we got an opportunity to build a project, which is 9 stories, 29 apartments, all in cross-laminated timber. And this really gave us the inspiration, the initiative, the kind of kickstart to really believe that this was a possible kind of and viable alternative to concrete and steel. And one of the things that we've done with this project and with our projects subsequently is to keep things very simple. You can see here just CLT, 3-inch galvanized shelf brackets, 5-inch screws, little plastic tags on the ceiling to run the electrics and the services through. And we built 4 people built the entire structure of this building in 27 days. So incredibly fast. Very lightweight, weighs about 20% of a reinforced concrete building, fewer deliveries, an 80% reduction in traffic, and very quiet. So we're about 9 meters away from an adjacent building. No complaints, no problems, because the whole thing is going together with cordless screwdrivers and precision. So in 2009, we made a conscious decision as a practice. We had a lot of interest in the building, a lot more than we realized, because we were just kind of like beavering away. That's a kind of appropriate expression, but beavering away in the corner on our fascination with this material, and looked up and looked around and realized that there was a lot of interest in what we were doing. And so we decided at that point as a practice that we would be completely open source about everything that we do. So we wrote this book, which is still available on Amazon. I think I get about 20p if you buy one. So, and in this book we put all the drawings, we put all the failures, all the kind of like where we'd succeeded, you know, and we really tried to be as open as we possibly could, and have done since then, been very open source about the materials and our experiences since then. This is our largest built project to date. This is 17,000 square meters, 10 stories tall in Dalston in North London, and 121 apartments. If we'd built that out of concrete, it would have been 10,000 tons of concrete, about 900 deliveries of concrete to site. But in timber, less than 2,000 tons, about 2,435 trees, which is about, for the 800 people that live and work in the building, that's about 3 trees per person in the building. So very efficient, very lightweight. The entire structure took 4 months to build. 2 teams of 4 people took 4 months. And you can see, incredibly fast. By the time the train has gone past, the building is finished. And then since then, we're not the only people building in cross-laminated timber, in engineered timber in the UK. So we have about 600 buildings across the UK made from engineered timber. And in 2018, we did a project for the US Department of Agriculture where we spoke to a lot of the developers, architects, contractors, engineers involved in those buildings. And we put together a book of 100 projects in the UK, which is full of drawings and interviews, and then kind of assimilated information which runs across different sectors, so residential, commercial, education, etc. And this is still available for free online at thinkwood.com. Then in 2018, we built this factory with Vitsu in Leamington Spa. And this is an interesting project for us. This is the first project that we were ever, where we were ever asked to build a timber building. All the other projects that we ever built in timber, and we've completed 26 CLT buildings now in the UK and France. And this was the first one where actually we were commissioned to build a building in timber. All the other buildings that we've built before then, we had to persuade people that building them in timber was more cost efficient and faster than building them in concrete and steel. So this building here is built from, and the reason why I've showed it is because it's about thinking about where we are as a practice in terms of researching into different types of engineered timber. So this is using a softwood CLT on the outside of the building, and then on the inside, it's using a hardwood LVL. So using, rather than planks of timber, using veneers of timber, stacked up veneers that form the beams and the columns of this building. And that, those structural pieces are as strong as steel in cross-section. And they provide, the beam across there is about 25 meters long and about 50 centimeters deep. So incredibly strong, incredibly rigid structure, which is then held together with this kind of external structural shell of the CLT. And you can see inside, I guess the other thing that this kind of project as well began to demonstrate to us was not only the kind of the speed, the ease, the accuracy of the construction process, but also that being inside one of these buildings, where we have the opportunity here to expose the timber, that being inside one of these buildings also has a kind of health and well-being benefit as well to the people that spend all day in that factory. Well, it was a factory, it's now a restaurant and a museum and a ballet school and a factory. This is a project that we have currently on site at the moment in Shoreditch in East London, which is where most of our projects are because that's where I live. And sort of lazily kind of building their own. So this is a 5,000 square meter office building using a similar sort of structural technology to the previous Vitsu project. We are using, here you can see this is a couple of weeks ago on site here, so using the beech LVL as the structural frame and then using the softwood CLT as the floor slabs and the core. So the entire building is made from timber above ground, 5,000 square meters of office made from 100% timber. Oh, sorry, LVL, I should explain. So LVL is laminated veneer lumber. And the difference is that cross-laminated timber is made from planks of timber. So planks that are laid out on a bed, like one of the ones behind you over there. And then those planks are laid in perpendicular layers and sprayed with adhesive. And LVL is a veneer. So you get the tree and you peel the tree. So with a beech tree, you peel that out, and you might get about 100 meters of veneer out of that. Then you slice that veneer up, and you stack that veneer, 4 layers parallel, the 5th layer perpendicular. So it's both strong in that way, but it also has a cross-grain strength as well, so it's very stable and very hard. And as I said, as strong as steel in terms of its structural capacity. So what we do with this building is we use the LVL to take all the gravitational load, and then we use the CLT to take all the shear forces in the building. So all the wind load in the building is taken by the CLT. So it's an incredibly strong, incredibly light building. Weighs about 20% of an equivalent concrete frame building. And in terms of the carbon in that structure, and I think it's very important to, this is something that just in the last couple of years we've really began to get hold of as a practice, is this understanding of the actual, being able to demonstrate the figures of these buildings, being able to demonstrate the kind of savings that we get by building buildings like this in timber rather than in concrete. In fact, if anybody's seen on the news, I was kind of like, last night with my calculator on my phone looking at it, but if anybody's seen on the news recently this big plant in Iceland, this multi-million-dollar plant in Iceland that sucks up carbon dioxide from the air and stores it in the ground in Iceland. Well, the amount of carbon saved in this building by building it in timber rather than in concrete is equivalent to 50% of a year's worth of carbon sucking by that machine in Iceland. So these projects make a big difference. These are not incremental small benefits. These are big benefits. And the benefits of carbon, the saving from embodied carbon rather than from operational carbon, is that it happens right now. So you're making these savings right now when we really need them, not over 60 years, which is how long operational carbon is counted. So you can see here that building that building in concrete would have been about 450 kilos per square meter of emissions, 265 in timber. But if you count the sequestered carbon, so the carbon within the timber itself, then actually you're down to less than 70 kilos per square meter, which is an incredibly low number. And in fact, even in that number, about 40% of the carbon there is from the basement. As you can see here, looking at the carbon in the structure, that you take out the carbon from the basement here, and you can see immediately that the amount of carbon savings. Even in a typical concrete frame building, the amount of carbon that's used to create a basement rather than a typical floor is about 5 times the amount. So we need to stop building basements. Again, this is a really, you can see what we've done here in terms of the detailing, how this building is put together. All the steel connections that connect the various pieces of timber together, those are fire protected by the timber structure itself. So we embed the steel within the timber to fire protect the steel. But very simple details as well, very kind of tectonic, very sort of understood, legible form of construction. And we have a timber curtain wall, and then on the outside of the timber curtain wall, we have timber solar louvers protecting the glazing from the sun. And that's what it'll look like. There you go. Lots of hipsters in Shoreditch. Our largest project currently is one that's a bit mired in planning at the moment, but in Bergen in Norway, it's 2,500 homes and a primary school, community centre, and it's floating on a lake in Bergen. And one of the reasons I want to show this project is because what we've begun to understand with this project is actually not how we just reduce our impact, but how we begin to try and make things better with our buildings. So just briefly, the way that the foundations on this building work is that they're full of oyster beds. And the oysters within the foundations that cling onto the foundations of the building filter the lake and help regenerate a lake that's been polluted for 50 years. We're also building in Milan with Lend-Lease. That's a 44,000 square meter office building, completely prefabricated in timber. Again, you can see very kind of like the interiors of these buildings, very pared back, really taking advantage and enjoying the natural materials. So we went from after the change in building regs in the UK, we went from an architecture practice in the UK who built housing in the UK, and we're now an architecture practice who build offices in Europe. But this is modular housing that we're doing for Swan Housing in East London. So looking just at the manufacturing process, you know, in terms of productivity in construction, productivity of the last 50 years in construction has gone down by about 20%. So we make buildings more slowly and more expensively than we did 50 years ago. So one of the things about we can help to cure that is to talk about the prefabrication. And prefabrication in CLT is a very straightforward thing to be able to do. So this is a building we have in East London, 65 affordable homes, socially rented homes in East London. And we've worked on design guides with them. And also, so I want to talk to you, behind us over here, we have a structure that we built a couple of years ago for the American Hardwood Council, who came to us with an idea for us to build a sort of a sculpture in the V&A courtyard. But we don't really do sculptures as a practice. But this is here, and this is some tulip wood that arrived here. And we made the tulip wood with the help of CSIC. Well, CSIC made the tulip wood with the help of us. Into cross-laminated timber. And we made these series of boxes that started as models here, and then you can see against that backdrop there, these were put together and then placed in the V&A courtyard. We had, it was there for about 3 weeks. We had 150,000 people come and see it, apparently, and 1.5 million Instagram hits. So we got our message out. We began to be able to really talk about the opportunities of structural timber and what you can do, the variety that you can, of kind of architecture that you can create. And we've actually taken this down since then, re-exhibited it in a different form in Milan, and took it down, re-exhibited it in a different form in Madrid. Now it's here and in the Design Museum and in a couple of other places as well. So it's still going. We're now, as a practice, about a third of our work is in research, a lot for the European Union, where we are researching different opportunities for timber over the 27 countries. And that includes a research project that we're doing with the Louders Foundation, built by Nature Fund in the UK, which is demonstrating that we can still build in timber in the UK within current building regulations. So this is a pre-warranted residential system for 6-story buildings, which is pre-approved by fire brigades, by insurers, and by warranty providers. And this will be released in December, beginning of December, and this is a completely open source set of information so that any other architects, clients, developers, contractors, etc. can take these drawings and build with them, so that we can help to kickstart net zero housing in the UK. And that will come with very straightforward, simple sets of details like that. Now, this is what one of the things I'm really excited and passionate about at the moment, is what we do with all the existing buildings that we have, and how we can help regenerate those buildings, extend those buildings by using timber. So this is a project that we have in Amsterdam at the moment, where we're using an existing 8-story concrete building to sort of be, if you like, the structural heart of the building, and then building a new timber building around it, using the concrete structure as the kind of like, as the sort of, to help with the wind loads. And then another one, which is a tower building, where we're putting 2 stories on top, but we're actually able to add additional floor area around the outside of the building without affecting the existing foundations. So we're able to increase the size of that building, therefore make it viable to keep the existing building. So how can we use timber to regenerate, to extend the existing buildings that we have, so that we avoid demolishing the buildings in our cities? And that is my last slide, thank you. That is the number of, that's the number of tree seeds that it took to grow the trees that built our first tall building. Thank you.
Thank you very much.